Okay, so number skills then. Now, there have been so many different topics that we've touched upon in the GCSE content this year already, of which I've seen a bit of a lack or a bit of a rusty spell based upon number skills. Okay, so I thought I'd create this video just to go through some things that we assume that you guys know already, or just a quick recap that you have seen before, but you need just refresh your memory in order to access some of the content that we're talking about this year. So these things have been seen in primary school, okay? But like I say, obviously they're towards the back of the mind and we need to bring them forward. So the first thing we're going to look for is multiples. Okay, so if I had multiples of 5, okay, multiples, think multiply, think times tables. Okay, multiples of 5 would be 5, 10, 15, 20, 25, etc, etc, etc. These are multiples. It's where you have first multiple of 5 is 5, second is 10, third is 15, etc. Sounds very basic, but a lot of people get this one, multiples, mixed up with factors. Now, factors are something different, because factors, some of you might be looking at the screen and going, yeah, factors are numbers that go into other numbers. You're totally right. I think of the X factor. The X factor is a competition that people enter. They go into the X factor. Therefore, factors are numbers that go into another number. However, it is very easy to miss a few out. Now, let's work out the factors of 24. I've seen various different methods over the years, and this method I was shown a few years ago, and I genuinely believe this is the best one for calculating factors. What number goes into every number in the world? 1. 1 times 24. Start with 1. Right, so we've worked out how many 1s go into 24. Now let's try 2. 2's in 24 because it's even. 2 12s are 24. Let's try 3. Does 3 go in? Yes, it does. 3 goes in 8 times. Does 4 go in? Yes. 6 times. Does 5 go in? No, because it doesn't end in a 5 or a 0. I don't need to try 6, because 6 is there. I'm going to draw a horseshoe around them, because these are my factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. Now, GCSE papers will say list the factors of 24, for instance. You can get 2 marks for a basic maths question based on factors. However, 2 marks for all of those. If you miss one out, you're now down to 1 mark. If you miss a second one out, you are now down to 0. So even though you've listed all of these factors of 24, but you've missed out these 2, you would get 0 marks for all of this effort. So, using the horseshoe method by starting with 1, then try 2, and then using your times tables to help, you will make sure that you get all of them every single time. I've seen different spider methods where you have 24 in the middle, and then you have 1 goes in, you go, oh yeah, 2 goes in, oh yeah, 6 times 4 is in, I know those 2. Oh, I know 12's in there somewhere. Yeah, oh, and don't forget 24, yeah. And I say that's the factors. However, you've missed out the one that most people miss out, 3 times 8. So, using this method, trying these numbers, obviously it does help when you're very good at times tables. Primary school teachers are constantly on at pupils about helping about times tables. As old school teachers, we're constantly saying times tables are the fundamentals of maths. They really, really are. Because we want to try and teach the harder things of the GCSE specification, whereas these things are the basics which we use in order to develop that learning. So, that's factors. Next one. prime numbers. Okay, prime numbers. Prime numbers, I ask my classes every year. Describe a prime number to me. They say a number that can only be divided by 1 itself, or a number that can be multiplied by 1 itself. Let's just think outside the box now. You can divide any number by any number. 0.6. You can literally divide anything by any number. Yes, it would give a decimal answer. So some people say it can be only divided by 1 itself without a remainder. Okay, so now it's getting a little bit more complicated. But we can eradicate all these problems with a few easy words. Exactly 2 factors. Let's pick a number. Let's go for 7. Factors of 7 are 1 times 7. Therefore, exactly 2 factors, it's a prime number. 11, 1 times 11. Does 2 go in? No. 3s? No. 4s? No. 5s? No. So therefore, 2 factors makes it a prime number. I'm now putting 9 on the board. Let's see how many factors it's got. 1 times 9. Oh, 3 goes into it, so that's 3 times 3. So it now has 3 factors, but a prime number only has 2. So it can't be prime. Okay. What about 2? How many factors does it have? 1 times 2. Oh, so it's got to be prime. So 2 is the only even prime number. So if you use this method to work out how many factors go into it, if it has 2 and only 2, exactly 2 factors, must be prime. So try and remember that instead of it can be divided by 1 itself. That makes it a little bit easier for you and very clear to see if it's prime or not. Next one, square numbers. Okay, square numbers. When you draw a square, and use these dots to help, you can see why it's called a square number and what the answer is. So the first square number is 1. Second square number, let's make a square. I've got 4 dots, so 4 is a square number. I've drawn a square, 3 by 3, which is 9. 4 across, 4 up. 16 dots. 16 is a square number. Five across, 5 up. I've now got a square number of 25. So this one is a square number. 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 And this one is a square number. Obviously 6 times 6, 36. 7 7 is 49. They are square numbers. That's where they've come from. So these numbers, 1, 4, 9, 16, 25, should, after a long time of using them, will be numbers that stick in your mind as special numbers, as they are square numbers. So that's a quick whistle-stop tour, if you like, of some basic number skills, multiples, times tables. Factors, horseshoe method. Start with 1 until you get all the way around to 24. Don't forget to list them in ascending order, from smallest to largest. Prime numbers, exactly 2 factors. If you write out like this, you will see very clearly the difference between a prime and a non-prime. Square numbers, when you draw them as dots, you can see clearly they are square numbers.